Okay, so one of the other number types we want to talk in more detail is fractions. Okay. Now, fractions are a type of rational number. Okay, and so as such, we use them very often. Later on, we'll talk about ratios and proportions. Okay, and especially some of the times when we don't use the same set of rules as we do for fractions. But anytime that we see a fraction, we have this set of rules that we will kind of default to go and deal with that. And without any additional context, we're always going to assume anything written in a form like this is a fraction. Okay? So we have A over B, where A and B are integers. Okay? But B can't equal 0, right? We talked about in the number types video. Something to keep in mind though with this is we say x over x equals 1, right? Anything over itself equals 1. True. If I have 0 over 0, this mathematically can equal 4 different things. Okay? And it all depends on which set of rules I'm working with at the time. So in early discussion, x over x always equals 1. So 0 over 0 can equal 1. Okay? And that's important for people to be able to understand. That's an acceptable answer for the set of rules that they're working with. Okay? You'll also say 0 divided by anything equals 0. Okay? When you start teaching about graphs and you're finding slope, you're going to have, a whole bunch of work, and you'll do your slope equation, and you get numbers on top and you get 0 on bottom. And what do we call that? We call that undefined. Okay? The fourth one is if the bottom of a fraction is approaching 0 or gets to 0, our number has infinite value. Okay? So if you think about like 100 over 100 equals 1, 100 over 10 equals 10, 100 over 1 equals 100. As my bottom number is getting smaller and smaller, getting closer and closer to 0, the overall value gets bigger and bigger and bigger. So if I had 100 over 0.1, that's worth 1,000. Over 0.01, 10,000. And as we get that closer and closer, eventually we get to essentially what represents 0, and that's some gigantic amount represented as infinity. Okay? So, coming back here, that's just a nice little side thing to ever, torture your students. You're confusing, or if you're in the middle of a big math conference and you won't be able to get out, you just say, hey, what is 0 over 0? And then people will start fighting with you because they're all working on a different set of rules. Okay? So, here we have A and B. A is known as the numerator. Okay? It's the top number of a fraction. Okay? Apart from being just the top number of a fraction, what does the numerator tell us? It tells us how many parts we have. And that's an important thing to know and understand. Okay? So this is the distinction on the number of parts that there are in our possession. Okay? It doesn't tell us too much about those parts. It just tells us how many we have. B here, the denominator, okay? It tells us how many parts make up a whole. Okay? So, if the numerator and the denominator are the same, I have how many parts make up a whole, because they're the same, right? So if this was 8 over 8, then I'd have one whole thing. Okay? Can I have more than one whole thing? Absolutely. We call that an improper fraction, or we can write it as a mixed number. And we need students to be okay with that kind of representation happening. Okay? The denominator number also tells us the size of the parts. Okay? Just yesterday, I'm talking to my daughter who's in 3rd grade learning about fractions. Okay? And the question was, which one of these two fractions is closer to 1? And I wasn't looking over her shoulder. I was doing something when she kind of shouted the question at me. And I had to pause and say, well, you want these two numbers to be as close together as possible. That's one way to indicate which one of them is going to be closer to 1. Okay? To which she, of course, replied, they're both a difference of 1. The fractions were 1/2 and 3/4. Okay? So then I said, well, in that case, let's look at the bottom number. And I came over and saw the fraction that she's working with. I said, okay, so this one, and she had little pictures to draw out. And here's my 1/2, and here's my 3/4. Okay. And she had learned, okay, I draw however many pieces there are on the bottom. This is what her diagram looked like. Okay? And so, this idea, I said, well, which one of these has a smaller piece away from 1? She's like, oh, it's this one, and she colored these in. Said, yeah, this one's fuller, and it gets her closer to 1. And that worked. She understood that visually, but I had to take a little bit of time because I'm a math nerd and say, okay, we see that this bigger number on bottom meant that we had smaller pieces. Okay? So when I was a kid growing up, we would have like some kind of cake dessert, and we'd bring it to the table and we'd set it in front of Mom. And it's important that we set it in front of Mom, because she would take it and she'd cut that cake pan into like 12 pieces, 12 nice sized pieces. And you're like, oh yeah. So you could sit there and eat it, and you were full, it was joyous and wonderful. Okay? If we set it in front of Dad, he would cut that into 48 little pieces and give everybody one, and then you'd have to come back and keep asking for one. So I understood this whole idea that this number, how many pieces there are, determines the size of the piece. Okay? We're saying parts, so I'll just say parts here. So the size of those parts is also determined by that denominator. Okay? So when these are both one piece away from the whole, this, because it has a smaller number, has bigger pieces. That's an inverse relationship. When students have a bit of a hard time understanding inverse relationships, because it's different than what we think. Bigger number means we should have more. No. Bigger number means we have more pieces and they are smaller. Right? We have to take that same line of thinking one step farther for them. Okay? And so being able to see to these parts, pieces, and what the numerator and denominator do for us, what they tell us about this problem. Now, every fraction is a division problem. I've kind of keyed at that a few different times. If you've ever actually looked at the division sign, it looks an awful lot like a fraction because they are interchangeable. So anytime that you see fractions or division problems, you can write them the other way to make them more friendly for you to use. Okay? So knowing that and being able to use that is really helpful for some students, because I don't think about all the fraction rules when I'm doing division. And so I like to put my division problems into fractions, and then I can jump forward. But sometimes I'm looking at this and I don't even know if I can reduce that. If I wrote it as a division problem, then I think about my divisibility rules, and I have those tools to help approach the problem. Okay, so here's all about your fractions, their parts and pieces, and that they're always a division problem in disguise.